spring 2025. The Ukrainian sun glints off the angular armor of the M2A4E1 Bradley Fighting Vehicle as it thunders across the dusty steppe. At 33 tons and nearly 22 feet long, this steel behemoth leads a column of American-made war machines. Their tracks churning up clouds of ochre earth on their way to reinforce national forces holding their ground against the Russian onslaught. Suddenly, the Bradley's advanced sensor suite detects incoming threats. Anti-tank missiles streak towards the column, their rocket motors leaving smoky contrails in the azure sky. In the blink of an eye, the Bradley's Iron Fist active protection system roars to life. Countermeasures erupt from its launchers, filling the air with a staccato of explosions. The incoming missiles disintegrate harmlessly, their deadly payloads neutralized by cutting-edge technology. The lead Bradley's 25mm chain gun swivels silently, scanning for new threats. Through its state-of-the-art thermal imaging system, heat signatures of Russian T-90 tanks appear on a distant ridgeline. Without missing a beat, the Bradley's powerful engine surges as it expertly maneuvers into a superior firing position. As the range closes, the Bradley's advanced fire control system locks onto the distant targets. Its precision-guided weapons stand ready to neutralize the enemy armor. Simultaneously, the vehicle's enhanced situational awareness systems detect incoming artillery fire. The Russian tanks have revealed their position, and the M2A4E1 is ready to show what it's made of. The M2A4E1 Bradley represents the pinnacle of American infantry fighting vehicle technology, born from decades of combat experience and technological innovation. Its story begins in the early 1980s when the original M2 Bradley entered service with the United States Army. Designed to transport infantry squads safely across the battlefield while providing fire support, the Bradley quickly became a cornerstone of American armored warfare doctrine. The Bradley's development was not without controversy. Initial concerns about its cost, complexity, and vulnerability led to extensive debates and modifications. However, its performance in the Gulf War of 1991 silenced many critics. During this conflict, according to some reports, Bradleys destroyed more Iraqi armored vehicles than the M1 Abrams main battle tank, proving their worth as both troop carriers and fighting vehicles. Over the years, the Bradley underwent several iterations, each improving upon its predecessor. The A1 variant, introduced in 1986, featured enhanced armor and a more powerful engine. The A2, which saw action in the Gulf War, boasted improved survivability and the ability to fire tow missiles while on the move. The A3, fielded in 2000, brought digital systems and enhanced situational awareness to the platform. However, as warfare evolved and new threats emerged, particularly in the urban battlefields of Iraq and Afghanistan, the need for a more advanced Bradley became apparent. The asymmetric nature of these conflicts exposed vulnerabilities in the Bradley's design, particularly to rocket-propelled grenades and improvised explosive devices, or IEDs. The M2A4 variant, first fielded in 2022, addressed many of these concerns with improved mobility, enhanced power distribution, and better protection against IEDs. This version featured a more powerful 675 horsepower engine, an upgraded transmission, and improvements to the suspension system. These changes allowed the Bradley to carry additional armor while maintaining its mobility. The development of the M2A4E1 began in earnest in 2024, spurred by the ongoing conflict in Ukraine and the realization that near-peer adversaries were developing increasingly sophisticated anti-armor capabilities. The United States Army, recognizing the need to stay ahead of potential threats, fast-tracked the program to create a Bradley that could dominate the battlefields of the future. The M2A4E1 program focused on three primary areas of improvement: survivability, lethality, and situational awareness. Engineers from General Dynamics Land Systems, the prime contractor for the Bradley, worked closely with experts from various fields to integrate cutting-edge technologies into the tried-and-true Bradley platform. At first glance, this latest version of the Bradley bears a strong resemblance to its predecessors, maintaining the iconic silhouette that has become synonymous with American armored might. However, A closer inspection reveals a host of improvements that set this vehicle apart from earlier models. The heart of the M2A4E1 is its revolutionary Iron Fist active protection system. Developed by Israel's Elbit Systems and integrated by General Dynamics, this state-of-the-art defensive suite provides the Bradley with unparalleled protection against a wide range of threats. The system utilizes advanced radar and infrared sensors to detect incoming projectiles, from anti-tank guided missiles to rocket-propelled grenades. When a threat is identified, Iron Fist launches a countermeasure that intercepts and neutralizes the incoming round before it can strike the vehicle. This capability dramatically increases the Bradley's survivability on the modern battlefield, where sophisticated anti-armor weapons are becoming increasingly prevalent. The Iron Fist system consists of 4 primary components: electro-optical sensors, fire control radar, a computer processing unit, and countermeasure launchers. The electro-optical sensors provide continuous 360-degree coverage around the vehicle, capable of detecting and tracking threats day or night. The fire control radar complements these sensors, providing accurate ranging and trajectory information for incoming projectiles. The computer processing unit rapidly analyzes this data, determining the optimal response in milliseconds. Finally, the countermeasure launchers deploy specially designed interceptors to neutralize the incoming threat. Complementing the Iron Fist system is a suite of improved passive armor. The exact composition of this armor remains classified, but it is known to incorporate advanced composite materials and spaced laminate designs. This enhanced protection is particularly effective against kinetic energy penetrators and shaped charges, further increasing the Bradley's ability to withstand hits from enemy fire. The armor package also includes improvements to the vehicle's underbelly, providing enhanced protection against IEDs and mines. The M2A4E1's offensive capabilities have also received significant upgrades. The vehicle retains the proven MM242 25mm chain gun, but it now features an improved fire control system that enhances accuracy and target acquisition. The new system incorporates advanced ballistic computers and improved stabilization, allowing for accurate fire on the move, even in rough terrain. The ammunition feed system has been redesigned to reduce the likelihood of jams, ensuring reliable operation in the heat of battle. The TOW missile system has been upgraded to fire the latest variants of these potent anti-tank weapons, capable of defeating even the most heavily armored opponents at ranges exceeding 4,000 meters. The new TOW system features improved guidance and increased resistance to countermeasures, ensuring its effectiveness against advanced enemy armor. Additionally, the M2A4E1 can now carry a larger complement of TOW missiles, increasing its staying power in prolonged engagements. One of the most significant improvements in the M2A4E1 is its enhanced situational awareness capabilities. The vehicle is equipped with a state-of-the-art high-definition, forward-looking infrared gunner's sight, providing unparalleled clarity in both day and night operations. This system is complemented by a network of high-resolution cameras that offer a 360-degree view around the vehicle, eliminating blind spots and enhancing the crew's ability to detect and respond to threats. What's more, the M2A4E1 features an advanced commander's independent viewer, allowing the vehicle commander to scan for targets independently of the gunner. This capability significantly enhances the Bradley's ability to acquire and engage multiple targets quickly, a crucial advantage in the fast-paced combat environments of the modern battlefield. Meanwhile, interior improvements have not been neglected. The fighting compartment has been redesigned to improve ergonomics and reduce crew fatigue during long operations. New blast-resistant seats provide enhanced protection for the crew and transported infantry, while an improved environmental control system ensures comfort in extreme climates. The vehicle's internal layout has been optimized to improve ammunition storage and accessibility, allowing for faster reloading and more efficient use of space. However, the M2A4E1 Bradley is not just about increased protection and firepower. It also boasts significant improvements in power and mobility. At the heart of these enhancements is a new, more powerful engine, This power plant, a Cummins VTA 903 ET 675 8-cylinder diesel engine, produces an impressive 675 horsepower, a substantial increase over previous models. This extra power is crucial for maintaining the Bradley's mobility despite the added weight of its improved armor and new systems. The engine's increased power output also provides the M2A4E1 with improved acceleration and hill climbing ability, crucial factors in combat situations where the ability to rapidly change position can mean the difference between survival and destruction. The engine's advanced design also offers improved fuel efficiency, extending the Bradley's operational range and reducing the logistical burden on supporting units. Paired with this engine is a new HMPT 803 ECB hydraulic transmission, which provides smoother power delivery and improved fuel efficiency. This advanced transmission features multiple forward and reverse gears, allowing for precise control in various terrain types and tactical situations. The transmission's design also incorporates advanced cooling systems, ensuring reliable operation even in the most demanding conditions. The combination of the new engine and transmission allows the M2A4E1 to reach speeds of up to 41 miles per hour on paved roads, ensuring it can keep pace with other elements of an armored formation. More importantly, it provides the power necessary to navigate challenging off-road terrain, a critical capability in combat zones where improved roads may be scarce or actively avoided due to the threat of IEDs. The Bradley's suspension system has also received attention. New shock absorbers, torsion bars, and track components work together to provide a smoother ride, reducing crew fatigue during long operations. These improvements also contribute to better off-road performance, allowing the M2A4E1 to traverse rough terrain more easily than its predecessors. The upgraded suspension system provides better stability when firing on the move, enhancing the vehicle's combat effectiveness. Another critical upgrade is the vehicle's power management system. The M2A4E1 features a smart power distribution network that efficiently allocates electrical power to the various systems on board. This is particularly important given the increased power demands of the new sensors, communications equipment, and active protection system. The improved power management ensures that all systems can operate simultaneously without overtaxing the vehicle's electrical infrastructure. The power management system also incorporates advanced diagnostics capabilities, allowing for predictive maintenance and early detection of potential issues. This feature helps to increase the vehicle's overall reliability and reduce downtime for repairs, a crucial factor in maintaining combat readiness. While the development of the M2A4E1 has been informed by the experiences of its predecessors in various operational theaters, including the ongoing conflict in Ukraine, as of summer 2024, the Bradley hasn't yet seen combat. Before sending it to the front lines, the U.S. Army plans to conduct extensive field exercises with the M2A4E1 to evaluate its performance in various scenarios. These exercises will simulate urban combat, open terrain engagements, and operations in challenging environmental conditions to ensure the vehicle meets all operational requirements. Military analysts anticipate that the M2A4E1's advanced features, particularly the Iron Fist active protection system, will significantly enhance its survivability on the battlefield. The improved optics and fire control systems are expected to provide a substantial advantage in detecting and engaging enemy vehicles at long ranges. Beyond its primary combat role, the M2A4E1 is designed with versatility in mind. Its enhanced sensors and communications systems make it a potentially valuable platform for reconnaissance and command and control functions. The Army also envisions using the vehicle in peacekeeping operations, where its imposing presence and non-lethal crowd control capabilities could prove effective in maintaining order without resorting to deadly force. Additionally, the M2A4E1's improved mobility and advanced communications suite could make it an asset in humanitarian assistance and disaster relief operations. Several NATO allies have expressed interest in the M2A4E1, recognizing the potential benefits of its advanced technology. Discussions are underway regarding potential foreign military sales and technology sharing agreements, which could lead to increased interoperability among NATO forces in the future. Looking ahead, military planners are already exploring ways to further enhance the M2A4E1's capabilities. The vehicle's modular design allows for relatively easy upgrades as new technologies become available. Ongoing studies are examining the potential integration of drone swarms, artificial intelligence-assisted target recognition, and even directed energy weapons. One area of particular interest is the potential for increased autonomy. While fully autonomous combat vehicles remain a distant prospect, there is significant potential for automated systems to take on more tasks, reducing crew workload and potentially allowing for reduced crew sizes. This could include automated threat detection and tracking, autonomous navigation in certain conditions, and even limited autonomous weapon engagement under human supervision. Another area of development is in networked warfare capabilities. Future upgrades may see the M2A4E1 serving as a hub for a network of unmanned ground and aerial vehicles, extending its sensor reach and combat effectiveness far beyond its physical presence. This concept, often referred to as manned-unmanned teaming, could dramatically reshape the way armored forces operate on the battlefield. Improvements in power systems are also on the horizon. Research into hybrid electric drives and advanced energy storage systems could provide future versions of the Bradley with even greater mobility and endurance. These technologies could also support the integration of high-energy weapon systems, such as lasers or railguns, which require significant power generation capabilities. However, the M2A4E1 is not without its critics. Some argue that its increased complexity could make it more challenging to maintain in the field, potentially reducing its availability rates. Others question whether such heavily armored vehicles will remain relevant in future conflicts dominated by unmanned systems and long-range precision weapons. There are also concerns about the cost of the M2A4E1, with debates arising about the balance between capability and affordability. Despite these concerns, the M2A4E1 Bradley remains a formidable fighting vehicle, embodying the best of American military technology and doctrine. Its combination of firepower, protection, and mobility make it a versatile platform capable of adapting to a wide range of mission profiles. As warfare continues to evolve, the M2A4E1 Bradley serves as a bridge between the battles of today and the conflicts of tomorrow, carrying forward the legacy of American armored might into an uncertain but undoubtedly challenging future. The true measure of the M2A4E1's capabilities will only be known when it faces the unpredictable and demanding conditions of real-world operations. As it moves closer to full operational deployment, the military community watches with keen interest. The lessons learned from its development and eventual deployment will undoubtedly play a crucial role in shaping the next generation of combat vehicles, ensuring that the United States remains at the forefront of armored warfare technology.